Hi, I'm Kathleen. Welcome to Color Theory for Painters. This is the first in a series of videos about color, which I'm going to be studying all year. And I thought it would be a good place to start at the beginning with color theory. We all love beautiful color, and as artists and painters, we just long to get that color and capture it and put it on our canvas. And we have our paint tubes that we need to mix together and make these colors, and that's where the challenge comes in. So naturally, we want to learn as much as we can about color theory. But what in the world is color theory? I went to the dictionary and looked it up, and I didn't find it, but I found three color theory, a theory of color vision that assumes three psychologically primary colors. That was not what I was looking for, so I continued to look and Googled it and found many articles about color theory. And they were all, it's all rather subjective, right? Because it's not something we can look up in the dictionary to tell us what it is. But most of the information about color theory surrounds these items. It starts with a color wheel. And it talks about the three components of color, which are value, chroma, and hue. And it talks about how to use the color relationships in the color wheel, like complementary colors, analogous colors, and warm and cool colors, etc. Well, I think those are great things to study, but I don't think that it's a good place to start necessarily, because as artists, we read the definitions of these things, but we say, well, gosh, how does that make me a better artist? How does that help me mix better color? So when I was delving into this, I thought, well, I've just got to go back more. I've got to dig deeper and find out more about this color wheel. Where did it come from? And the color wheel is credited to Sir Isaac Newton, who was a scientist and a mathematician, a philosopher, kind of a Renaissance man who was studying light in the 1600s. And what he did was he took a white light and he shot it through a glass prism, and out the other side came a beautiful spectrum of colors. Well, this was a well-known party trick back then, and everybody knew that this happened. But I think that Newton kind of got credit for the whole thing, because he took the experiment a step further, and he used another prism where he shot. He had two prisms, one where the white light was going through and breaking up into the colors, and then he put another prism there for the colors to go through, and guess what? It recombined into the white light. So, wow, it kind of proved the theory that the colors were in the light and not in the prism, like everyone thought, right? So, does that mean that all the color that we see is actually only light, and objects are not really colorful? That's kind of a theoretical rabbit hole we could go down, but not today. This is his drawing that they found in his notes, where he, took the colors that he saw, the Roy G. Biv colors coming out of the color wheel, and he put them on this circle. And so we know that he was one of the first people to come up with the color wheel, and we ultimately use it today as in this version, where we see the red, orange, yellow, green, blue, indigo, and violet surrounding the wheel, and we use the Roy G. Biv acronym to help us remember each of those colors. So remember, though, I want to remind you that we're talking about light here, mixing light. The color wheel was the color wheel that artists use today was invented through mixing light. So that's a little different than our application. I just want to point that out, that we're not to that mixing paint stage yet. We're still only talking about light, and it does have a relevance to mixing color, but it's good to understand the whole scientific background. And we said that mixing all the colors of the spectrum produce a white light, but actually you can get the same white light from only 3 colors: green, red, and blue. So these are called the primary colors of light, or additive colors. So here's a way that I like to remember that term, additive mixing, because this is different than mixing paint, which is called subtractive mixing. I imagine a big old theater with spotlights of color being shined from above. One may be red, one may be green, one may be blue, and they're mixing all together to produce the white light. But they could also be mixed together. The lights can mix the red and blue to make magenta. The lights can shine the lights so that the green and blue are together and they make a cyan on the stage. And guess what? If you combine the red and the green, it makes a yellow, which is certainly not true when we mix colors on our palette, is it? So that's kind of a surprise that green and red light make yellow. We could see the other ones, like the red and the blue making magenta. That's something we can kind of we could do with our paint. We can mix some green and blue and get a cyan. That makes sense to us, but the green and red is very unique to light mixing. So red, blue, and green are the primary colors of light. How does this relate to our mixing colors? Well, let's keep going. Imagine an apple in the light. When the white light hits the apple, we don't see all the rainbows of colors that are in the light, but now we know they're there, right? So what happens is that all of the wavelengths of color are absorbed into the apple except the red wavelength. The red wavelength is reflected off the apple, and the reflection is what our eye sees. The receptors in our eyes see this, transmit that information to our brain, which determines the color, and in this case, it's red. So our eyes only see the color wavelengths that are reflected back to our eye from an object. This is an important point when we continue to talk about color mixing later. Now let's consider something that is perceived as white. A white object will reflect all of the light back into our eyes. So no wavelengths are being absorbed into that white object. The light is all reflected in our eye, and that's why we don't see any color. Now consider something that's black. When the white light, imagine it, as a white light, and we know it's got all the colors in it, red, orange, yellow, green, blue, indigo, violet, is hitting that black object, all of the colors absorb into the object, and we see no light. And since we see no light, since we see no color, we view the object as black. So all of the color that's in the light is absorbed into the black object, and no light is reflected back at our eyes. Interesting, huh? Well, that's a lot of information for today. And so I'm going to continue next time talking about how this kind of relates to mixing paint, and go into that what's called subtractive mixing of mixing paint together, mixing pigments, and how they relate together. So thank you for joining me today. I will see you next time.